Assalamualaikum and good day to everyone. Today I will be presenting my FYP project entitled Development of Exhaust Gas Recirculation System in Industrial Burner Application. The increasingly worldwide problem regarding exhaust waste heat and environmental issues has been highlighted heavily recently. In conventional burner system, not all heat generated will be converted into useful mechanical work. The remaining heat is expelled to the environment through the exhaust gas, resulting in entropy rise. Therefore, it is required to take into account the potential of reusing and recycling the waste heat for beneficial work. Waste heat from conventional burner can be used to tackle the problem regarding high viscous oil to be used as fuel. One of the examples of high viscous oil is spent bleaching earth oil or SBE oil, which is a waste generated by palm oil refineries during the process of bleaching. The viscosity of SBE oils is very high, which is 93.8 centistoke at 40 degrees Celsius. The high viscosity of the SBE oil is due to the presence of free fatty acids. Exhaust gas recirculation system can be used to heat up the oil without external energy with just some conceptual integration and modification of its system design. Several studies have shown that heat from exhaust gas can be used to preheat fuel before undergoing combustion. However, there is lack of design or fuel preheating system in the EGR for industrial burner application, as most of the studies mainly focus on preheating operation in internal combustion engine instead of industrial burner. So, how does the fuel preheating system affect the burner operation performances? Well, preheating the fuel before it enters the combustion chamber will increase the temperature of the fuel and reduce the fuel kinematic viscosity. Viscosity is basically the thickness of the fluid. The lower the viscosity, the less thick the fluid will be and the easier and smoother it will flow. Reducing the kinematic viscosity of the fuel will improve atomization. For atomization, it can be visualized as somewhat similar with the application for the water spray. It is the process whereby bulk big-sized liquid is transformed into a collection of drops. As the atomization improves, the surface area of the fuel droplet will be larger as its size has decreased, which makes it easier for the fuel droplet to mix and collide more effectively with air particle as it enters the combustion chamber. Thus, this will improve combustion. Therefore, less power will be required for the combustion to take place. Therefore, it is required to take into account of utilizing the waste heat for preheating purposes, especially for high viscous waste oil that fuel the burner and eventually reduce the power consumption of the said burner. In order to design a compatible fuel preheating system, the aims that need to be established includes finding the best concept for the fuel preheating design implementation, selecting the right material that are compatible for the fuel preheating operation, and simulating the design of fuel preheating system using computational software such as Autodesk CFD. In this project, I will address the challenges of finding out the best conceptual designs that can heat the oil in the storage to reach 100 degrees Celsius at the shortest amount of time. Because at 100 degrees Celsius, the SBE oil have reached a quite optimal viscosity before entering the combustion chamber, which is at 13.2 centistop. Then, brainstorming on the properties and variables that affect the fuel preheating system are done. Variables that affect the fuel preheating system include shapes, dimension, material, wall thickness, and methods of heating. Based on the brainstorm, a few concepts for the design are then created. The software that is used for the CAD drawing to illustrate the design is Autodesk Fusion 360. There are 4 conceptual designs that will be tested. The first concept is using heater-like coil. The concept works by using the hot exhaust gas to travel along the heater-like coil and undergo heat transfer, where the heat is absorbed by the coil via conduction before transferring it to the SBE oil. The heater-like coil is positioned at the bottom part of the tank. The second one is through direct helical coil piping inside the tank. For this concept, the hot exhaust gas travels along the helical coil and transfers the heat to the SBE oil. The third concept is focused heating to the storage base and rest ambient temperature. In this concept, the exhaust gas also will be contained inside the gas chamber and rest the ambient temperature of the oil storage before exiting. The last and the fourth concept is using repurposed water heater tank as reservoir. The type of burner used for this project is fixed, which is a waste burner goes with the brand King valve. The minimum oil consumption of this burner is 2 liters per hour. The selection of pump, pipe, and thermocouple suitable for the system are made to check its compatibility in the EGR operation. For the setup, the system equipped with EGR mechanism, which is designed by pumping the exhaust gas out from the chimney or the combustion chamber itself to allow the hot exhaust gas to recirculate back after passing through the fuel preheating system. 4 thermocouple is connected to the system, which are situated at the pipe before the fuel enter the reservoir, after the fuel enter the reservoir, before the exhaust gas enter the outer gas tank, and after the exhaust gas enter the outer gas tank, respectively. To better design the system, it is important to address the factors that can affect the heat transfer in accordance to the thermodynamic laws, such as pressure and mass flow rate. In terms of result, the variables that affect the system are manipulated and a total of 12 simulations are produced. For each design simulated using Autodesk CFD, a spreadsheet and graph will be generated by the software. Based on those data, the number of iterations required to increase the average temperature of the fuel to 100 degrees Celsius is recorded and tabulated as follows. Based on the comparison of results from the simulations, the best way to heat up the oil is by direct heating to the tank base and increase ambient temperature using copper tank equipped with heater as reservoir, as this concept design only requires 18 seconds to reach the desired temperature of 100 degrees Celsius. The concept works by transferring the fuel from the fuel tank to a smaller tank that is obtained and repurposed from conventional water heater that act as a reservoir. The reservoir is then heated using the exhaust gas contained in the gas chamber surrounding the reservoir and can be heated further using heating element connected to the electrical AC supply that is built in the reservoir. In conclusion, this project has been conducted in order to tackle the lack of design of field preheating system in EGR operation for conventional burner. Using software simulation like Autodesk CFD enables the author to find the fastest way to heat the fuel at specific temperature of 100 degrees Celsius in order to achieve the targeted fuel viscosity of 13.2 centistock, which is optimum before entering the combustion chamber. And these are some of the references that I use for guidelines throughout my final year project. With that, ladies and gentlemen, thank you for your kind attention.